Okay, class, picking up where we left off at, it says simplify or explain why it cannot be simplified. With this problem here, if we go back to the previous problem where we had a radical and we had two terms, I had you all put could not take the cube root of each individual term or could not take the square root of each individual term. Now, what we could start doing, instead of writing all of that, we could just write cannot be factored. Okay, that would take care of A. Now we come here to B. We have the fourth root of x to the fourth, y to the fourth. We know the fourth root of x to the fourth is just x, and the fourth root of y to the fourth is just y. Now, we come down here to C. Now, if you notice here, we have the fourth root of parenthesis x plus y to the fourth power. Now, we could rewrite this as x plus y in parentheses to the 4 over 4 power. We know that this index becomes the denominator of the fraction made with this exponent. So this would be 4 over 4, which would just leave us x plus y, because we know 4 over 4 is 1. Now we come here to D. We have the square root of 16a to the 16 over b to the 10th. So we could separate that. We got the square root of 16a to the 16 all over the square root of b to the 10th. Now let's rewrite this as an exponent. First of all, we know the square root of 16 is just 4, so let's just take care of that. But the square root of a to the 16th is the same as a to the 16 divided by 2. All over. The square root of b to the 10th is the same as b to the 10th divided by 2. As we know, we would take this exponent and divide it by the index. So this would give us 4 a to the 8th all over b to the 5th. And that is the final answer for that problem. Now we scroll down here to E. Now we have the square root of 16 minus a to the 16th all over b to the 10th. Now we can separate that. The square root of 16 minus a to the 16th all over the square root of b to the 10th. Now, first of all, we know that this is the difference of two squares, but it really doesn't matter here because number one, even when I'll just write it out just so you can see this. We know that this will end up being 4 minus a to the 8th times 4 plus a to the 8th. And this would be all over the square root of b to the 10th. We already saw that it was b to the 5th from the last problem. Now, we cannot do anything with these values here. So what we could do is this here. We could just rewrite it back to what it was. It would be the square root of 16 minus a to the 16 all over b to the 5th. And this would be the final answer. Now we come here to F. Now we would separate this. We have the 5th root of 243, the 5th root of x to the 20th, and we will have the 5th root of y to the 35th. So the 5th root of 243 is just 3. The 5th root of x to the 20th, we know that that would be 20 divided by 5, which would give us x to the 4th. And the 5th root of y to the 35th, 35 divided by 5 is 7, so it would be y to the 7th. And that's it. Now we scroll down here to example 3. It says the time t in seconds it takes an object to fall d feet is given by the formula t equals the square root of d over 4. Niagara Falls is 169 feet tall. How long would it take a stuntman in a barrel to go over the falls and land in the water below? Find by hand. So we have t is equal to the square root of, we know d stands for the feet, which we are told that is 169, all divided by 4. Now, The square root of 169 we know is 13. And 13 divided by 4 will give us 3.25 seconds. And that is our final answer. Now, class, we will move on to 9.1, Part 2, Simplifying Radicals, Removing Perfect Nth Powers. Now, what I'm going to do is this here. These values here will substitute in for x squared, and it will give you the following values. I'll just write these in. You could also test these out in your calculator. And then the next group, this will be to the third power. And then last but not least, this will be to the fourth power. Of course, again, you can test this out in your calculator. This is all of these charts filled out. It says how to simplify a radical with an index of n. You must identify all perfect nth powers that are factors of the radicand. Use the product property to separate the factors and then simplify where possible. Example 1. It says square root example. It says simplify the following. We have the square root of 54x to the 6th power. Now, first of all, we need the highest perfect square out of 54, which we know is 9. And we know it'll be 6 remaining. Now, I like to separate my roots where I have all the perfect roots in the first radical, and then everything that's left in the second radical. Now, x to the 6th power, we know there's a perfect square in x to the 6th power. The square root of 9 is 3. The square root of x to the 6 is x cubed. And then we'll bring down our square root 6. And we're done. Now we have the square root of 75, x to the 7th. The highest perfect square in 75 is 25. And you add 3 left over. The highest perfect square in x to the 7th is x to the 6th. And you will have 1x left over. The square root of 25 is 5. The square root of x to the 6th is x to the 3rd. And we'll bring down our square root 3x. Now we come here to C. Now we have the square root of the parenthesis 4x minus 1 to the 13th power. Now the highest perfect square here would be parenthesis 4x minus 1 to the 12th power. And then what's left in this second radical is parenthesis 4x minus 1 to the first power. So this will leave us 4x minus 1 in parentheses to the 6th power. That's what comes out of this radical. And under this radical, we'll be left with parentheses 4x minus 1. We don't have to write the 1 power. And this is the final answer. Now we come here, the square root of 80, a to the 9th, b to the 2nd. The highest perfect square in 80 is 16. And we know we'll have 5 left over. A to the 9th, the highest perfect square is a to the 8th. And we'll have an a left over. Now b to the 2nd, we know b to the 2nd is a perfect square. So now the square root of 16 is 4. The square root of a to the 8th is a to the 4th. And the square root of b squared is b times the square root of 5a. And that's it. Now, we come down to the next page here. Now, this page here is technically not required, but I'm still going to go over it anyway. Okay, now there was a slight typo here. It has 54 to the 6th power. It's supposed to be x to the 6th power. So it's supposed to be 54 x to the 6th power under this radical. So we have the cube root of 54x to the 6th power The highest perfect cubed is 27. We have the cube root of 2 left. And the perfect cube, x to the 6 is the perfect cube. And this will give us 3x squared cube root of 2. Now we go to the next value. We had a cube root of 40, x to the 10th. The highest perfect cube in 40 is 8. And you will have 5 left over. The highest perfect cube in x to the 10th is x to the 9th. And you have an x left here. Cube root of 8 is 2. The cube root of x to the 9th is x to the 3rd. And you have a cube root of 5x. And this will be your final answer. Now we scroll down here to C. We had a cube root of 4,000. The highest perfect cube in 4,000 is 1,000, with 4 left over. Now, the highest perfect cube in m to the 14th is m to the 12th, which will leave m to the 2nd. And the highest perfect cube in n to the 4th is n to the 3rd, and it'll leave n. Cube root of 1,000 is 10. Cube root of m to the 12th is m to the 4th. And the cube root of n is just n. And you will be left with the cube root of 4m squared n. And that will be your final answer. Now we come here to D. We had a cube root, the highest perfect cube in 16. We know is 8. Highest perfect, well, with 2 left over. Highest cube root of a to the 6, we know that a to the 6 is a perfect cube. And the highest perfect cube in b to the 10th is b to the 9th. That leaves us a b. Cube root of 8 is 2. Cube root of a to the 6 is a squared. Cube root of b to the 9th is b cubed. And we'll be left with the cube root of 2b. And this is our final answer. Now, we scroll down to E and F. Now we're dealing with these fourth roots. Now just to streamline this a little bit, we have the fourth root and also the fourth root. Now the highest fourth root in 48 is 16. Highest fourth root in a to the 3rd, well, we have 3 left over. There's no fourth root in a to the 3rd. The highest fourth root in b to the 8th is b to the 8th. And the highest fourth root of c to the 21st is c to the 20th. And that will leave a c here. Fourth root of 16 is 2. Fourth root of b to the 8th is b squared. The fourth root of c to the 20th is c to the 5th. And it'll be the fourth root of 3a cubed c. And that will be your final answer. Now, we come here to F. We do the same thing. The fourth root, the fourth root. So we will have 625 with 10 left over. We will have x to the 12th with x to the 3rd left over. The fourth root of 625 is 5. The fourth root of x to the 12th is x to the 3rd. And we have the fourth root of 10x cubed. And this right here is your final answer. Now with our next problem here, we need to fill in the table, which we have here. You can fill this in, and we need to plot those points. And if you notice here, our end point, which is our lowest point, which is 0, 0, and then this goes on to infinity, because this graph will keep going on if we keep putting in points. Our next point will be 36, 6, and so on. Now, we scroll down here to objective 3. You can read all of this at your leisure, but it says find the period of a pendulum whose length is 2 feet. So this I stands for the length of the pendulum. So we will substitute in these values here. We will put in 2 for I, and we will have 2 pi times the square root of, we simplify this. This is 1 over 16. It'll be 2 pi times 1/4 after we take the square root. 2 pi times 1 is 2 pi, and 4 will be in our denominator. We can simplify the 2 and the 4, which will leave us pi over 2, and we put this in our calculator, and it will give us approximately 1.57 seconds. And that is it.